Hello, everybody. Let's have our last class for this week. And the last sub-chapter of the chapter is, let's say the last section of the chapter is substitution and the area between curves. In the previous video, actually, we talked about indefinite integrals and the substitution method. Okay, now we'll just apply that method to definite integrals. Okay. So, guys, you're going to have quiz most probably on Monday. Okay, expect this next quiz from chapter 5 on Monday. So, most of them will be calculation. You will be calculate and solve the problems. And since you are allowed to use anything, okay, the question will be maybe I'll ask more questions, but you need to be a little bit fast. Okay. So, let's see, maybe you'll have 20 or 10 questions. So, we'll see. So, what are we going to talk about here? Actually, here we are going to talk about two different methods, but they're very similar, but a little bit different. So for a definite integral by substitution, one method is to find an antiderivative using substitution and then to evaluate the definite integral by applying the evaluation theorem. And the other method extends the process of substitution directed to the definite integrals by changing the limits of integration. And we will use a new formula that we introduce here to compute the area between two curves. Anyway, so the method is simple now in the previous lesson, right? If you're given an indefinite integral, and if it is possible to calculate this by substitution method, we know the idea how to evaluate this. So after evaluating this, we know that we just pick any one antiderivative of the function, right? And just calculate its value at b and a and find the difference. Actually, that gives us the result of this definite integral. That's it. That's not so complicated. And let's just give this as a theorem, and we will use this theorem to solve the problems. So if g prime is, not g prime is continuous on AB, and f is continuous on the range of g of x, and is equal to u, then g prime of x dx that's equal to this. Why is it so? Let's say here, again, if we look at this, let's say, let me just label this integral by a. So this a is equal to okay. So this a is equal to integral from a to b. Here we have f of g of x, right? And here we have g prime of x dx. Again, if you just look at this part, what is it? It's just a differential of g of x, right? So I can just write it as integral. I'm not changing anything from a to b, f of g of x, and here we have d of g of x, right? So now from here, if I introduce the thing, and suppose that u is equal to g of x, right? And see here, this x, actually this one is a, and this one is b. And since we are saying that the g prime is continuous, right, and also f is continuous, that means that when x takes values from a to b, g takes values from g of a to g of b. So that means that if x equals a, then u is equal to g of a. And if x equals b, and here we have u is equal to g of b. Then I can just change this then. Here we have, instead of a, right, that actually our u is changing from g of a to g of b, and here we have f of u, and here we have du. Okay, so that's very, almost the same with substitution method. Just here we have integration limits. As immediately, let's apply it to this. We have already calculated this in the previous lesson. And again, once again, let's say this integral is equal to, let me introduce this variable. U is equal to x cubed plus 1, right? So from here, we know that then du will be equal to 3x squared dx. And how about the integration limits? Also integration limits, as see here, if u is equal to x cubed plus 1, if x equals -1, then what is u? U is -1 cubed plus 1, that's equal to 0. So if x is equal to 1, then what is u? U is 1 cubed plus 1, that's equal to 2. So at that time, our I becomes here integral, and u is changing from 0 to 2, right? And instead of this 3x squared dx, I can write du, and x cubed plus 1 is u. So here we have square root of u, and here we have du. So that's equal to integral from 0 to 2. Here we have u to the power of 1 over 2 du. And we now have to integrate this 1 over 2 plus 1, that's equal to 3 over 2. So here we have 2 over 3 u to the power of 3 over 2, right, from 0 to 2, which is equal to 2 over 3. And here we have only this 2, here we have 2, 3 over 2 minus 0. So which is equal to, that's equal to 4 over 3 square root of 2. That's the integral. Okay. So what is the second method? Second method is I'm not actually changing anything here. Let me just give a show you, but you can do it yourself. Here, the second method is this is the first method. Okay. The second method, without introducing any variables, I can calculate this. I can just write it as -1, and here we have 1, and here we have x cubed plus 1 to the power of 1 over 2, and here we have d, right? And here we have x cubed plus 1. As you see here, the differential x cubed plus 1, we have 3x squared, right? So now, here we have the same thing here, x cubed plus 1, x cubed plus 1, right? So that is equal to x cubed plus 1 to the power of 3 over 2 over, here we have 3 over 2, integral from -1 to 1. That's also the second method, but which one is suitable for you? You can choose either method to solve your problems. Next, evaluate the definite integral by using the method of transforming the limits of integration. So we are just going to use the first method. Suppose that this integral is equal to a, and I'm going to calculate this integral a. So again, what is it? This cotangent of theta times cosecant squared of theta, right? And if you remember here, one thing is, let me just write here, cosecant squared of x, right? Derivative, that's equal to minus cosecant of x times, I think I better write the cotangent first. I can write here cotangent of x times cosecant of x. Okay, so what does it mean? It means that, these are for notes, let's say. So that means that the differential of, what is it? Cosecant of x is equal to minus cotangent of x times cosecant of x. Here we have dx. Okay. So let's move back to our question first. So a is equal to integral from pi over 4 to pi over 2. This cotangent times cosecant squared, I can just write it as cotangent of theta. Let's say theta. Cotangent of theta times cosecant of theta, right? And okay. Anyway, let me just write here again, cosecant of theta. Here we have d theta. So as see here, instead of this cotangent of x times cosecant of x dx, right, I can write minus d cosecant of x. So at that time, here we will have what we have here. Here we have cosecant, right? So it is minus, so this minus integral from pi over 4 to pi over 2. And here we have cosecant of theta. And d, here we have cosecant of theta. Why is it so hard to write cosecant? Cosecant of theta. Okay. So now if I just introduce here, u is equal to cosecant of theta, right? From here, then, if theta is equal to pi over 4, right? Then u is equal to cosecant of pi over 4, that's equal to square root of 2. If theta is equal to pi over 2, right? So then u is equal to u is equal to 1. Because cosecant means 1 over sine, right? Sine of pi over 2, that's equal to 1. 1 over 1, that's equal to 1. So at that time, our integral takes this form. So that a will be, the u is changing from square root of 2 to 1. And here we have, actually also here we have minus, here we have u du, which is equal to minus 1 over 2 u squared from square root of 2 to 1 equals minus 1 over 2. 1 of this 1 is equal to 1. 1 of the square root of 2, that's equal to 2. So that's equal to 1 over 2.
Professors,
Yes.
I think you will let u equals to sine.
Sine?
Yes,
What do
because
you mean?
let u equal to sine, and
Are you
because
trying to say that there's a mistake here, or you're suggesting a different method?
um is that okay?
Is there any mistake here? Do you see any mistake here?
Just let me try to think. I will find.
Okay, you try. Okay, if there is any mistake, I think I'm just using, we know that the derivative cosecant of x, that's equal to minus cotangent of x cosecant of x, right? As see here, we have cotangent of x times cosecant of x times cosecant of x. So, and just using the differential and introducing the variable. Okay, and try this. If there's anything wrong, let me know. We'll come back and discuss this more. So now we are going to actually prove two important, simple but important theorems, especially when we just use this, we can save a lot of time, okay, using this substitution method. The first one says that if f is continuous function and symmetric over the interval, minus a and a, I mean the symmetric interval, this one is symmetric, right, about the origin, minus a to a. So if f is even function, then integral from minus a to a, f of x dx is equal to just 2 times integral from 0 to a, f of x dx. And the second one is if it is odd, then this integral is equal to 0. Okay, actually, the first one, I mean, let me just change this. Okay, this should be at the top. This should be at the top. Actually, it refers to the first one, and this is the second one. Okay. So the first figure, as you see here, it is symmetric, right? Since it is symmetric and our function is even means its graph is symmetric also. That means that just if this area is A, and also this should be A. So we don't have to calculate this integral from minus A to A. Just calculate 1 from 0 to A and multiply by 2. Okay. So why is this so? I'm just going to make use of this, what is the substitution method to prove this. And just to give you some idea, the first part is part A. Okay, so let's say our integral is I. Okay, so we are going to calculate this from minus A to A, and here we have f of x dx. And keep in mind that f of x is even function. And what is the definition of even function? That is f of minus x is equal to f of x. So now I can just write it as from minus a to 0, f of x dx plus 0 to a, f of x dx. Okay, so now the first part, actually, the first part, I can just write it as, what is it? Minus, and just interchanging the integration limits from 0 to minus a. And here we have f of x dx. And for just now, okay, let me just denote this one as I1, and this one is just I2. Okay, this one is I1, and this one is I2. Okay, and this I1 is equal to this. So equals, I will continue here, equals. Now if I use substitution method, okay, so I will introduce this one. And suppose that u is equal to minus x. Okay, so at the time when x equals 0, u is equal to 0. When x equals minus a, right, u is equal to a. So at the time here we have minus, and here we have 0, right? And f of x, I can just write it as minus a. Let me just write one more time. I can write it as f of minus x because it's even. F of x or f of x, it gives us the same result. This minus bring inside, okay? I'm just going to write here. Here we have minus x. Now I'm going to substitute u for minus x. So at the time integral, and when x changes from 0 to minus a, u changes from 0 to a. And here we have f minus x is u, and d minus x is u. Now again here it's just f of u du, right? It's just a variable. Again, I can put anything here. So that's the same as from 0 to a, f of x dx. So that is the same as the second part of the integral, and which is equal to 2 times integral from 0 to a. In similar way, when it is odd, if you just calculate this, actually, see here, these areas, numerical values, the same, but only the signs are opposite. That's why they just cancel each other if they are odd function. All right, let's just apply this to this question here. Evaluate the following integral. Without using this one, we can use the evaluate this. But if you look at the function, this function is all the powers of x, they are even. So that is an even function. So this integral is just simply equal to 2 times integral from 0 to 2. Here we have x to the power of 4 minus 4x squared plus 6 dx, which is equal to, because when one integration limits to 0, it is much faster. So that is 2. Here we have 1 over 5 x to the power of 5 minus 4 over 3 x cubed plus 6x, right? And it is changing from 0 to 2. When it is 0, everything is 0. When it is 2 here, we have 32 over 5 minus it is 32 over 3 plus 12. Okay, and simplify and you get the answer. How about the second one? If you look at this function, it's f, right? And f of x. So f of x is odd function because here we have f of minus x equals minus x to the power of 5 minus 4 times minus x cubed. So from this minus, I can just take this out. That's equal to x to the power of 5 minus 4x cubed. So that's equal to minus f of x. It is odd when our integration, what is it, interval, it is symmetric about the origin. So simply that's equal to 0, even we don't have to try to calculate this. Okay, so now let's talk about areas between curves. Okay. So if f and g are continuous with f is greater than g, or A can be equal at some points throughout AB. Then the area of the region between the curves y equals f and y equals g from A to B is just the integral of f minus g. Okay, so the idea is very simple. We are talking about two functions, and suppose that f is greater than or equal to g. That means that the graph of f is above the graph of g. So let's say the graph of f is something like this. So this one is A, and this one is B. And this is our function f of x. And our second function, let's say it is something like this. Okay, so that's our g function, g of x. Okay, so now we are saying that the area between them are bounded by the line x equals a, x equals b, and f of x minus g of x that's just equal to this. Why is it so? Because we know that to calculate the area, right? And just one simple thing is, let me just write this area by A, okay? And this one is B, all right? So what is A then? We know that A is equal to, right? I mean, not A plus B, right? What is A plus B? A plus B is equal to integral from A to B. If it is positive here, just here we have f of x dx. And how about the area B? It is our function, g function, right? And it is the area which is shaded by red color. So that's equal to integral from, again, A to B. It is g of x, and here we have dx. Now, what is actually area A then? Area A is equal to A plus B minus B, which is equal to the integral, right, from A to B, f of x, right? And integration limits, everything is the same. We can just combine them, minus g of x, and here we have dx. And of course, these conditions, they are continuous, and f is greater than or equal to g. Otherwise, we have to divide this into some subintervals, and where these conditions are satisfied, then we could use this formula. Example, find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals minus x. So first, of course, if you have laptop or software, immediately we should draw this, and after we consider this. If not, how can we do that? First, we need to find algebraically. Suppose that, because these are not so complicated, the first one is just parabola, right? 2 minus x squared. It looks downward, and when it is 0, here we have, and here we have, what is it? Minus square root of 2, and here we have square root of 2. So its graph is, let me draw this in green, its graph is something like this. Anyway, something like this. It's parabola. And how about y equals minus x? So first, let's find actually the intersection points. Right? To find the intersection points, number one, we need to solve this equation. That 2 minus x squared is equal to minus x. Where do they intersect each other? Or simply just a quadratic equation. We have minus x minus 2, that's equal to 0. Or we can factorize this, x minus 2, x plus 1, that's equal to 0. So that is when x equals -1 and when x equals 2. So when x equals -1, right here we have -1, -1, they intersect each other somewhere here. Okay. Okay, -1. Okay. And when it is 2, right, when it is 2, it is somewhere here. Actually, I need to write here, this one is 2, it is somewhere here, let's say. So we are talking about this region, okay? So this point is, this one is 2, and when it is 2, is 4, right? It is minus 2. When this one is 1, -1, when it's -1, x is equal to 1, okay? So the question is, what is the region enclosed by these two graphs? We are talking about this region, right? So as you see in the picture, actually, which one is greater? Which one is greater? And this one is right function y is equal to 2 minus x squared. That is about this line. This one is y is equal to minus x. And to find this area, let's A, at the time the area will be from -1 to 2, right? -1 to 2. And here we have 2 minus x squared minus the second function is minus x. Here we have dx. Or if you just write this in standard form, let's say -1 to 2, here we have minus x squared, and minus minus it is plus x plus 2 dx, which is equal to minus 1 over 3 x cubed plus 1 over 2 x squared plus 2x from -1 to 2 equals, when it is 2, here we have minus, when it is 2, minus 8 over 3 plus 4 over 2, that is 2 plus 4, minus, when it is -1, 1 over 3 plus 1 over 2 minus 2. Okay, so now from here, if you just simplify this, what we have here, okay, minus 8 over 3 fractions minus this one is 5 over 6, 5 over 6. This one is 6 minus minus, it is plus 8. So that's equal to by 2 is minus 16, minus 16 minus 21, 8 minus 2, 16, 8, 21, 21 over 6. Or by 3, it is 7, 8 minus 7 over 2, 16, that's equal to 16 minus 2 times 8, 16, 16 minus 7, that's equal to 9 over 2. So the area between these two curves, or the region which is enclosed by the graphs of these two functions, is 9 over 2 units. All right, 3 examples left, and after that, I'll finish. All right, another example, find the area of the region in the first quadrant that is bounded above by y equals square root of x, and below by the x-axis and the line y equals x minus 2. So again, here we have, okay, here we have y equals square root of x. Its graph is something like this. Now immediately let's find again, where do they intersect each other? Square root of x is equal to x minus 2. In the first quadrant, that means that x is positive. If you square both sides, we can see that actually one solution is x equals 4, right? Because if x equals 4, square root of 4 equals 4 minus 2. So that means that when x equals 4, y is equal to 2. So let's say they intersect each other here. And this one is, it is 4, and this one is 2. So they intersect each other. X minus 2, its graph is when x equals 2, this is equal to 0, right? And when it is 4, that's equal to 2. So we are talking about this region. So this region, we are talking about this region. Okay. All right. So how do we find this region? If I just evaluate, right, this integral from here to there, actually, what is it? It gives us the whole region until 4, right? If I just subtract this triangle, let me just shade this by purple. We're talking about this triangle, okay? So then it gives us the area of the shaded region. So this A, what is A then? So what is the area of the triangle? This one is 2, right? And this one is 2. And how about the height? Height is 2. And let's say B, right? The area of B is equal to 1 over 2 times 2 times 2. That's equal to 2 units squared. Right? So now if I just find the A plus B, what is A plus B? So A plus B is equal to integral from 0 to 4 is just square root of x and dx. Okay, I'm just using a bit different method because here, if you just find this one integral, it gives us the region which is bounded by the curve, right? And the x-axis and the line x equals 4. So that is equal to, it is 3 over 2. So 2 over 3 x to the power of 3 over 2 from 0 to 4, which is equal to 2 over 3. When it is 0, it's equal to 0. When it is 4, here we have 4 cube root of 2, and which is equal to 8. So that is 16 over 3. Okay, that's number 2. So number 3, what is A then? A is A plus B minus B. A plus B, that is 16 over 3 minus, how about B? B equals 2, which is equal to 10 over 3 units squared. Okay, how about integration with respect to y? And we are just going to interchange the roles of x and y. But now here we don't have dx, but dy. Sometimes actually integration with respect to y will be much easier than integration with respect to x. Okay, and again, the idea is, as you see here, if you're talking about these two graphs, let's say this one is g of y on the left-hand side, f of y, right? And that is the length of this small rectangle. So actually, how do you find the distance between 2 points? If this one is x1 and this point is, let's say, this x2, the distance, that's the length of the rectangle, that's equal to x2 minus x1. So what is x2? X2 is the function on the right-hand side. That's why here we have f of y. And what is x1? It's the function on the left-hand side. That's why we have g. So we need to subtract the function on the left from the function on the right. This is how we determine the distance between 2 points on the x-axis. So find the area between the curves x equals y squared and x equals y plus 6. Okay. So we have, okay, 5 minutes. I will finish this soon. All right, if you draw your curve, okay, here we have x equals y squared, right? So that means that if this one is y and this one is x, okay, so just momentarily, you can just change to describe this one. Suppose that this one is x, this one is y. At that time, what we have here? Here we have this kind of function, right? X equals y squared. You know, that is just a parabola. So its graph is something like this. Its graph is something like this. Okay. And that is the graph of the function. What is it? That is x is equal to y squared. Now, how about the second one? The second one is x equals y plus 6, right? And we know that x equals y plus 6, it's just a straight line. To draw it as a graph, just we need to identify 2 points. So first, for example, if y equals minus 6, for example, x is equal to 0, right? So that means that 1 point is here. Anyway, another way is, let's just find where do they intersect each other. To find this one, we need to solve this equation. Y plus 6 is equal to y squared. So from here, y squared minus y minus 6 is equal to 0. So y minus 3 and y plus 2, that's equal to 0. So at y equals 3 and y equals negative 2, they intersect each other. Number one is, if this one is, let's say, y equals negative 2, it is somewhere here. And the y is equal to 3, it is here, okay? It's somewhere here. So they are intersecting each other here, like this. So now to actually find the area, right, as see here, y is changing from negative 2 to 3. So the area will be equal to, we are talking about this area. So integral y is changing from negative 2 to 3, right? And if we just find a distance here, right, I need to subtract this parabola from this, the straight line. The straight line equation is y plus 6 minus parabola's equation is y squared. And here we have dy. Because now here our height is not vertical, it is horizontal. Now from here, if you just integrate this function, the first one is 1 over 2 y squared. Second one is 6y. Third one is 1 over 3 y cubed. And y is changing from minus 2 to 3. And when it is 3, here we have 3 squared, 9 over 2, and 3 plus 18 and minus 27 over 3 minus 9. Minus, when it is negative 2, 4 over 2, that is 2, minus 12, minus it is plus, it is 8 over 3, which is equal to, here we have 9, 9 plus 9 over 2, that is 13.5, and minus 10, it is minus plus 10, it is plus 10 minus 8 over 3, which is equal to, let me just write this 3, it is 30, 30 minus 8, it is 22, and okay, 22 over 3 plus, okay, 22 over 3, here we have 22 over 3 plus 13 over 5, 27 over 2, which is equal to, here we have 6, 2 times 22, it is 44, 3 times 27, it is 81, 125 over 6. Okay, guys, that's enough for this week. That's all. And you also need to do your homework and submit next maybe Wednesday or Thursday, okay, to your TAs. And you're going to have quiz on Monday, 1 hour quiz again, okay. And next week we will start chapter 6. Okay, we're going to have class on Wednesday and Thursday, Friday. Have a nice weekend. I wish you good luck. See you next week.
Bye, sir.
Bye bye. Thank you, Askara.